Welcome to Knowledge Share channel. In this video, we will be discussing about digital to analog converter. Digital to analog converter. It is in short. It is called as DAC. That is DAC. Digital to analog converter. So, what is the use of this digital to analog converter? It is used to convert digital signals to analog signals. So, as you know that the signals are of two types. One, it can be in digital form, that is in case of that is called as binary form, that is zeros and ones, which is understood by computers and other digital systems. Whereas the sensors and transducers does not understand the binary logic, and it will be able to understand only the analog signals, actual magnitude. So there are two forms of signals. One is the digital signal, the other one is the analog signal. And there are various applications where we need to convert the digital signals to analog signals. Some of the applications are like instrumentation systems, then CRT display, as well process control systems. So these are all the applications of the digital to analog converter, that is DAC. So here you can see the block diagram. Okay, so here you can see the block diagram of the DAC, that is digital to analog converter. So here you can see that it is having n-bit binary word, that is D1, D2, Dn-1 up to Dn. So D1 is the MSB bit, whereas Dn is the LSB bit. So this is the binary word which we are going to input, and along with that we are going to give the reference voltage. So this reference voltage will be added according to the the digital binary input, and finally the output voltage will be derived. So the output voltage V0 will be given by Vr into D1 2 power n minus 1 plus D2 2 power minus 2 plus up to Dn 2 power minus n. So here Vr is called as the reference voltage, and D1, D2 and Dn are called as the n-bit binary words. D1 is the MSB and D2 is the LSB. And you know that D1 will be having the weight of Vr by 2, whereas D2 will be having the weight of Vr by 2 power n. So here you can see that the MSB will be having more weightage. So based on that, the output voltage magnitude also will be increased, and similarly LSB will be having less weightage, because it is the LSB will be having the voltage of Vr divided by 2 power n, and because of which the voltage can be reduced accordingly. So there are three types of DAC, that is digital to analog converters. So one is called as the binary weighted resistor DAC, the other one is called as the R2R ladder, and third one is the inverter R2R ladder. Many other types are there, but here these three are the basic elements of any DAC. So in this we will be discussing about the binary weighted resistor DAC. Okay, binary weighted resistor DAC. So binary weighted resistor DAC. So how it works. Okay, it uses OPAMP summer. Okay, so binary. Before going to the circuit, let us discuss what are the different parts of the binary weighted DAC. So it uses OPAMP summer. It adds n binary weighted currents in 2R, 4R due to the voltage Vr. The switch positions are controlled by means of the digital inputs. When the digital input is 1, then it means that it will behave as a closed circuit. When the digital input is 0, it behaves as a open circuit. So here let us go into the circuit diagram. So here you can see that, so this is the Vref which is given over here, and the op amp is having 2R, 4R, 8R and similarly 2 power n R. Okay. So according to the value of resistance, the current flow will be varied. So here you can see that for example for D1, if the D1 switches on, it is having the resistance of 2R. Similarly, if D2 switches on, okay, it is having the resistance of 4R. Similarly, if D3 switches on, it is having the resistance of 8R. Similarly, if Dn switches on, it is having the resistance of 2 power nR. So here you can see that based on the logical that is binary input, the corresponding switches will be switched on and off, and by means of this the summation of the currents. So this is nothing but a summer. Okay, so this is nothing but a op-amp summer. So summation of the current, there is a total current. So total current will be equal to that is I1 plus I2 plus I3 plus IN. So this is what is given over here. So the total current will be equal to I1. So according to the digital inputs that is switched on and off, you can see that the IT will be changed in the corresponding magnitude. And you know that the op-amp input impedance is very high, because of which the IT will not flow through this op-amp, it will flow through only the feedback resistance. So by deriving it, and you can see that, so V naught will be equal to minus IT into RF. So this minus represents the phase shift. Okay, so since it is a summing amplifier and we are giving to the negative terminal, so it will be having a phase shift. And finally we will be deriving like minus into I1 plus I2 plus I3 up to IN. And if you write the corresponding expressions, that is I1, for I1 it is nothing but D1 into VR by 2R, and for I2 it is nothing but D2 by V into VR by 4R. So like that it goes on, and finally you will be getting the expression like if you just simplify, you will be getting minus VR by R into this particular RF by R. And suppose if I take RF equal to R, so this is for example, if I take RF equal to R, then you will see that your expression V naught will be equal to minus VR into D1 into 2 power minus 1 plus D2 into 2 power minus 2 plus D3 into 2 power minus 3 until Dn into 2 power minus n. So from this equation it is understood that the analog output voltage is directly proportional to the input digital data. So here the table also has been given. So for example, if 0 0 0 0, the output voltage will be 0. If it is 0 0 0 1, the output voltage will be 1. If it is 0 0 1 0, the output voltage will be 2. So similarly, like that you can see that you can get from 0 to 15 volts as output by for different values of the binary digital data input. So this is the digital data input and this is the analog output we are getting. So corresponding to the for example 1 1 1 1, we will be getting the output voltage as 15, or 0 0 0 0, we will be getting the output voltage as 0. So this is how this that is analog to digital to analog converter is working. There are many types, and here we have discussed about the binary weighted digital to analog converter. So thank you for your time, and I hope this video would have given you insight into the digital to analog converter, and I have described about the binary added type. If you really like this video, please give a like, and as well please give a comment, and if you really find this video useful to somebody else, please share it. As well if you like the content which I post in this channel, please subscribe to my channel. Thank you very much.